I don't know, you make it bored out there. So, what I do in my space.
Okay. So let's continue now. So we want to approximate. So from part A. Okay, so from part A, we have that t sub 3 of x equals 1 minus x over 2 plus x squared over 8 minus x to the third over 48. And so now all I do is plug in x equals 1 to estimate what e to the negative 1/2 is. So I have 1 minus 1/2 plus 1 squared over 8 minus 1 to the third over 48. Okay, so now we want to simplify by finding a common denominator, which is 48 in this case. So I just find a common denominator of 48 minus 24 plus 6 minus 1 over 48. And that gives us 29 over 3. Okay, so if you didn't know what e to the negative 1/2 is, okay, you didn't have a calculator, you could estimate that it's about 29 over 48, okay? And so now, if you want, you can do long division here and get 0.60417, or about 0.60417. Okay, so f of 1, which is e to the negative 1/2, is approximately 0.60417. And so in the problem, I gave you that it actually equals 0.60653. So since actual value is 0.60653, okay, it's a good approximation. So that's the power and beauty of series here. We can use series to estimate, okay, if you evaluate a function. So if you want to find e to the negative 1/2, we can just estimate it by using a Taylor polynomial, all right, and we can see that 0.60417 is pretty close to 0.60653. Okay, so we have good approximation. Yes?
If it was a higher, like, t sub of something, like say it was t sub 5, would it be closer to...
Yes, the higher the degree of the polynomial, the closer you are to the infinite series, because you're adding more terms of that infinite series. Yeah. Mm-hmm.
On the exam, would they make us do the long division?
No, unless, I mean, if this was a question on the exam, they would either leave it in fraction form, or it would be, you would be given a very easy fraction that you can convert to decimal. Okay. So yeah, normally in this class we work with fractions. However, I wanted to convert to decimal form to compare the approximation. Yeah.
So is that pretty close to the sum of the series?
Yeah. So the sum of the infinite series was this 0.60653 because e to the negative 1/2 is equal to the sum of the series. Yeah. Any other questions? Okay. So next example now.
So is everything like a sum of a series?
What do you mean is everything a sum of a series?
Like anything like e to the negative 1b, or like can any function be a sum series?
Can any function be represented by a series?
Yeah.
Is that what you're asking?
I guess, kind of. Because then
No.
because you can't always find the sum, right? If it's not Taylor.
Right, so not every function can be represented by a series. Okay, however, if you're asked to find a Taylor series or something, we're just assuming that it could be represented by it.
Okay.
Okay. Sorry, represented by a Taylor series. alternating series remainder theorem?
Yeah, for this. Because you have
For
like,
this.
you have, you know, you can put,
I didn't even do the problem yet. How do you?
or, okay, with this one, it's e to the negative x over 2, right? You put that in the,
So that yes, you could. Yeah, you could because it's an alternating series. If it's an alternating series, you could use alternating series remainder theorem. However, I'm not going to have you do that. I'm just going to have you work with this new thing called Taylor's inequality. Okay? Alright, so before we get to Taylor's inequality, I just want to do the first part of this next example. Okay, so we do the same thing here. We find the third degree Taylor polynomial of the function f equals ln x. And so here n equals 3 because n is just a degree. Okay, so I write f, which is ln x, and then I find the derivatives 1 over x, negative 1 over x squared, and 2 over x to the third. Then I evaluate x to the zero. So, oh, sorry, 2, not 0. Okay, so I have ln 2, then I have 1/2, then I have negative 1 over 2 squared, which is negative 1/4, and then here I have 2 over 2 to the third, which is 2 over 8, or 1/4. Then I write out the original formula here. Okay. Make sure to always write out the original formula when you're doing these problems, okay? The more you write it out, the easier it is for you to memorize later on, okay? And then I can see if you're plugging things in correctly, because if I see that you get the answer wrong but I don't see what you plugged in where, then it's hard for me to give you as much credit. Okay, so always write out the original formula. And so now I've plugged f and all its derivatives into the formula. Okay, so I have f of 2 is ln 2. F prime of 2 is 1/2 over 1 factorial times x minus 2. F double prime is negative 1/4. 2 factorial times x minus 2 squared. And then f triple prime is 1/4 over 3 factorial times x minus 2 to the third. I just simplify that. I have ln 2 plus 1/2 divided by 1 factorial is just 1/2. So I have x minus 2 over 2. Minus 1/4 divided by 2, so negative 1/8. So x minus 2 squared over 8. Minus that. And then plus 1/4 divided by 3 factorials, 1/4 divided by 6, that's 1 over 24. So x minus 2 to the third over 24. And this approximates the function ln x. Excuse me. Why are we yawning? It's very exciting stuff.